Hey, hey, hey! It's Friday. It's sunny outside, or at least here in Lomma where I live. I hope it's sunny where you are too. And we're here again to quench your thirst for knowledge. So I'm 𝙒𝙗𝙗, software developer at 𝙗𝙤𝙗𝙢𝙗𝙧, and I'm here together with my dear Slovenian colleagues, Žiga and Klemen. So, hey guys, how are you doing?
We're fine, thank you.
Great.
Really, really good.
Great. You've been in quarantine for quite some while now. How are you holding up?
Well, it's a bit lonely, but after 3 weeks, we got used to everything.
Well, it's good at least to do this together with you and do it remotely so we can have some time together.
Yep, but we have slightly better weather this week, so
oh, that's nice.
It gets better.
Yeah, I've seen that some of you sit outside and do your work. I'm quite jealous of that.
With the perks of living close to the Mediterranean coast, I would say.
Yeah. So this will be quite front-end heavy talk, right? Where you will be talking about Flutter versus progressive web apps. Can we expect a battle from you?
I wouldn't say it's exactly a battle. It's more of like a comparative journey. They're both just pieces of technology that we can use and leverage to formulate and create beautiful and useful experiences for our users. So I'm sure they both fit their use cases, and we're going to try and explore what those are.
That sounds good. So before we start, I want the audience to get to know you a little bit better. So I figured that would play a little game called Two Truths and a Lie. So it's quite easy. I just want you to tell me two true things about yourself and one false thing. So after the talk, we'll reveal which one was the lie. All right?
Sure, sounds good.
Žiga, you want to start?
Yeah. Let me think. The first one is that I play classical piano. The second one is I played the guitar in a heavy metal band in high school. And the third one is I've been performing as a Balkan folk music DJ in high school. I'll let you decide which is which.
One way or another, you seem to be a quite musical guy. What about you, Klemen?
So the first one is I almost never wear socks of the same color. The second one is I understand monads when it comes to functional programming. And the third one, I use skateboard to commute daily to my work.
Okay, interesting. Well, I look forward to hearing what are the truths and what are the lies. So as usual, if you in the audience have any questions, please post them in the chat and I'll make sure to forward them after the session. And since we like to make things better iteratively, I'm happy to announce that this will be our first interactive session. So during this talk, you will be able to participate by casting your votes in a poll, which you can find at poll.𝙗𝙗�37.co.de. That's poll.𝙗𝙗�37.co.de. But you will find all this information here in the stream. So anyway, I think that's enough of me talking. I'm eager to start, and I think that you are too. So I will hand over to you, Klemen and Žiga.
Thank you.
Awesome. Thank you. Hello, everyone, and a very warm welcome from both of us to the Flutter and PWA session that is focused on building performant mobile frontends. And this is actually an upgrade of a session that me and Klemen already had in our offices last December. Maybe some of you today were already with us then. But today we're doing this with a slightly different twist, considering these dire circumstances that we are currently in. We're going to start by examining the status quo and reflecting about the purpose and business value of multi-platform development, and then further proceed by diving deeper into both Flutter and PWA and drawing some comparisons at the very end. Before we continue, huge thanks to 𝙒𝙗𝙗 for moderating this session today, and also to Nate for awesomely producing the stream behind the curtain. It's the first time for us that we're doing something like this as well. So transforming this talk to still work online was definitely a journey on its own. My name is Žiga. I work as a front-end developer at 𝙒𝙗𝙗𝙗𝙗𝙗𝙗𝙗. I'm really passionate about creating apps and interfaces that the end users actually enjoy to use and want to use. Otherwise, I've had previous experiences working in startups that I have co-founded, also as a freelance consultant, and I have an academic background in finance. Joining me today is Klemen.
Hi, my name is Klemen. I'm a software developer and I create immersive user interfaces with software and hardware. And as a kid, I really liked to read choose your own adventure stories. And as a huge fan of Black Mirror, I was so thrilled when they announced their Bandersnatch. So choose your own adventure edition of Black Mirror. So we did the same today, and we're presenting you our choose your own presentation kind of talk, and I hope you will like it.
Awesome, thanks. But first things first, before we continue with our talk, we have to deal with some technicalities, and I think it's very wise for us to test the setup and see if we can get the polling system actually working. So whenever you see a funky cat photo with a big and obvious poll time title, please change your tabs and cast your votes. We have a slight delay between what we say and what you hear. And oh, whoa, people are really jumping on it already.
Yeah.
We have a slight delay between what we say and what you hear, but we have some chatter prepared, so everything won't seem that much awkward. So let's try it out. Let's do the warm-up round. We're interested in hearing on what you're mostly focusing on in your current role. And we can already see that the vast majority of you is coming from development. But it's really, really cool that we have some product people and some designers joining us as well today, because we feel that this is going to be valuable for all of you.
Awesome. So it looks like most of people are developers. Yeah, or deal with development in their work life.
Okay, I think this seems like it's working. Let's try another one. So considering the current state of affairs, we're interested in hearing what is your current status. Are you working from home? Do you have some free time and you're rather spending that on learning new things? Or are you relaxing on a somewhat unsolicited vacation?
Yeah, we're still.
It's really awesome to see that although the vast majority of you is working from home, you still were able to find the time to spend an hour with us here. So thanks for that. We know it's quite hard to balance your own personal things with the stuff that you need to deal with at your job. Awesome. I think this is confirmed. At least the majority of you can vote. So I guess the only thing that's left now is for us to start with the session. And we want to kick off today's session by reading you a statement that describes the current and future state of affairs on the web. We're interested to know whether you agree with this, that the future of web is mobile. And now let's repeat the practice from before. Please tell us, how do you feel about this sentiment? Do you think that the future of web is mobile, or do you rather think that it might be something else?
But what are your thoughts on this, Žiga?
I'm a very mysterious person. I never disclose my secrets.
Okay, I can't wait to find out.
Awesome. So I think that this final result won't change. 80% of you said that this is correct. But now I want to take some time and reflect on this. I'm going to show you a couple of statistics because numbers give us confidence in our statements, right? I don't expect anyone to be particularly shocked by this, but they are a strong confirmation to what we're trying to prove. Today, 51% of all internet traffic is already mobile. And 90% of all internet users have mobile access. 98% of all internet users in China are mobile. And a very similar situation can be observed if we look at internet user statistics for other developing countries as well. In the US, the vast majority of users spend their mobile time in apps. And to say that the future of web is mobile, we believe is misleading at best. We're way past that, because the majority of users' time is already spent on mobile devices today. And the most screen time on mobile is spent in apps. So today, mobile is already a given. And there are new devices like smartwatches and smart TVs, smart glasses. I've seen some smart mirrors even being invented as we speak right now. So I want to show you a slightly revised statement that today, the future of web is actually embedded, or it might be something else because the future is unclear. But what we can really safely state and confirm is that today of web is already mobile. So we have to make sure that we still account for that when we're discussing our users' needs and our customer needs. And we need to make sure that these consumer needs are met. We need to bring our technology to them. We need to bring our technology to their mobile devices and possibly in the very near future, even beyond that. We really need to make sure that we stay productive as web developers, cut time to market, and release regularly on all platforms. And to do that separately and to learn the ins and outs of every platform just to formulate the UI is very inefficient and very time consuming. And time is money. And lots of developers working in environments are faced with very limited resources. Actually, most of us do. And it's hard to imagine separate development teams working on meeting these expectations on so many different devices, especially for small companies. Without significant backing, how can we expect that small startups can still compete with big tech giants in satisfying the consumer needs in all these different platforms? We believe that multi-platform development therefore ensures that these same teams can still deliver features on various platforms and therefore keep both today's and future's web accessible. But what do you think? Have you ever thought about multi-platform development in this way, or just generally the purposes that it serves? It's poll time, so please change your tab and cast your votes. Do you find multi-platform development purposeful?
I mean, I do. I really can't imagine developing an app and then figuring out that I chose the completely wrong platform. That would be a huge loss of time and energy from my side.
I mean, probably even the big tech giants like Facebook think that multi-platform development serves a purpose. Otherwise, probably React Native and similar tools wouldn't have ever been invented.
Yeah.
Yeah, so 93% of you think that multi-platform development is purposeful, and 5 of you still don't agree with us. But let's continue and see if we can convince you to change your minds. We have to think about what other purposes multi-platform development might serve today or in the future. And are the ones that we've mentioned the only ones? Do we have to sacrifice performance, user experience, and developer experience even just to meet these expectations and be able to satisfy all our end users at the end, and that we can still deliver on all required platforms. Well, we think that that's not actually the case, because the technology is changing and the frameworks are changing and our users are changing as well. And today we are way, way beyond just the digitization, and how we interact with our devices and technology has changed significantly over the years. Today, we live in an era where our users expect instant gratification and feedback. In 2000, the average human attention span was 12.5 seconds, and it was already 4 seconds lower in 2015. When the modern computer was first invented, the technology was not very accessible. Operating with punch cards and later with terminal user interfaces was reserved for only the most technological adept. Computers was not something that was meant for the general public. And we've came a very long way since then, a very long way also since keyboard and mouse were first invented. With graphical user interfaces, personal computing became a lot more accessible. And people who otherwise weren't interested in computers started to buy their own. But today, this is changing even further. Today, our users expect natural and immersive interfaces that blend technology with the physical world. Using swipes, gestures, pinches, dictation, and even face recognition, we have to strive to develop applications that integrate with our users' lives in unobtrusive ways and enable them to spend more time in interactions and more meaningful ways. And that's awesome that we're doing that. But what is the key to us ensuring that our technology is satisfying to use for our users and not frustrating? What is the key for us to ensuring that our users won't uninstall the app and remove it? Well, they need to work, and they need to work well. So they have to be very performant. So let's dive in and see whether we can build a strong case for performance in developing applications in the browser with PWAs. And Klemen will take over and explain to you just exactly what those are.
Yeah. Thanks for making a case for multi-platform development, Žiga. So when we look at progressive web apps, we see web apps that give users a native app look and feel. They're reliable, fast, and engaging because our users don't have internet connection all the time. And if websites were just websites, we couldn't really use them without the internet and on slow connections, because our bundles are getting bigger and bigger. And for those with a slow connection, this can get really painful. But with progressive web apps, we can solve most of those problems. The experience is fast, since we can offload lots of things in the background. We can provide smooth animations and transitions like native apps do, and even provide complex graphical components with WebGL. So our users should feel engaged. They should get notifications if that's their case. They should receive instant feedbacks and see when app is loading, or if it's in a different state, or it's waiting for something. And we can even create AR experiences on web with only the browser. And that covers most of the native things.
Yeah, but that's not the only thing, right? Because they're also very, very familiar.
Yeah,
Essentially, we're dealing with the same technology that we've been dealing for the past 10 years.
Yeah, we can just add some knowledge to that and create our web apps into PWAs.
And the cost of implementation is really low as well, right? Because transitioning from a traditional responsive website to a progressive web app does not take a lot of effort. What do we need to do that?
I mean, we just need to include a manifest that tells the browser that this is a progressive web app. We can set its title and then icons and say that it can be displayed in the full screen mode, like a real app. And that's it. Most of the browsers will just prompt the users to download our website, and start using it as a progressive web app.
Awesome. Considering that this technology has been with us for some time now, we're very eager to hear if you have any experience working with PWAs. So it's poll time. The wonderful cat is on the screen, and please change your tab and cast the votes.
So most of the people are focusing on user experience. And I do think that's a really great concern when it comes to apps. Because if you have to zoom into the app to use it, that's not an app.
But are performance and design also a part of user experience, or are they something entirely else?
They definitely are. Like, performance can be seen when it's not there. So mostly the lack of performance is noticed by the users. And design is also part of a user experience, since you can't have a good app if it doesn't look really nice.
Yeah, exactly. Awesome. It looks like most people agree with us that user experience is really important. That's a sentiment I share as well. And I feel that both design and performance are somewhat a part of user experience. I can hardly imagine a very intuitive app being a good experience for the user if it's laggy or if it looks very, very unpleasant to the eye. But still, to talk about performance of progressive web apps and the user experience of progressive web apps, essentially, is to talk about the performance of the website running in the browser. And at the core of that is the browser render cycle. As soon as the browser receives data from your servers, or any servers, in fact, it starts parsing your markup, HTML to the document object model to the DOM, a tree structure it can understand based on the HTML encoding, and CSS to the CSS object model in a separate cascading tree structure. The browser then combines these two in a unified entity named the render tree. And after that's done, the browser will start with the layout phase, taking in the render tree and computing exact positions and sizes of each and every node that should be displayed within the document. When all sizes and positions are known, the paint will take in the final render tree and paint the pixels on the screen on multiple layers. At the very end, in the composite phase, the browser needs to put the layers back together, ensure they are in the right order, and display everything to the window. And this all absolutely needs to happen before the first render is complete. But you most likely have other rendering blocking resources in your render tree, like JS. And the browser will run JS scripts whenever it encounters them, dependent on whether they are imported or inline. After that, the JS event loop will run continuously and monitor your application for any functions that it needs to put in the execution stack and run. The outputs of these are very often going to influence what information you display to the user and how. So when animating things in the browser, it's very good for us to understand that we're dealing with different phases or stages in the browser render cycle. When we're animating positional attributes like width or height or top left, bottom right, that's actually rhymed. We have to know that the browser will have to go through all the three stages again. So recalculate positions, paint every node to a layer, and then composite them back together. A better thing we can do is to only change or animate color properties, for example, only the attributes that influence the paint cycle, because if we do that, the browser can skip the layouting phase, which is also known as a reflow, which is also the most expensive one, and only has to do the paint and composite phase. But actually, where we should be most of our times when animating nodes in the browser, we should use transforms to only influence and restart the composite phase, because that one is also the most easy to run for the browsers and happens the fastest. And the reflow and paint don't need to happen.
So Are you saying that we shouldn't animate fonts and sizing and backgrounds and like top and left positions?
Yeah, well, yes and no. I actually read a really awesome quote on the developers.google.com website. And they say that performance is the art of avoiding work and making any work you do as efficient as possible. So it's important for you to know what you're doing, because when things are good, everything seems okay. Current devices run on 60 frames per second, and future devices will run on twice of that at 120 frames per second. And if you can't ensure consistent performance, your apps are going to start janking. And probably your users are going to become frustrated with how your app is performing. In the worst case scenario, they're going to hate you for it, uninstall the app, and never use it again. So
Yeah, we
it's
don't
really
want that.
important. Yeah, it's really important for you just to know what's happening. So when you start to get performance issues, you can very easily debug them or make your app perform better again. But sometimes, I mean, even if we do all those things and never animate anything at all, we still don't get the results that we need, because nowadays we're getting more and more used to fat front-end clients that do a lot of heavy lifting. And now Klemen will show you what we can do in those cases.
Yeah, so when it comes to calculations, we only have 16 seconds for each frame if we want to achieve 60 FPS, 16 milliseconds. And if our work that we want to do requires more than that, then we would need to split this work in chunks and create our own system for that. And as a lazy developer, not lazy, but laziness is a great driver, I don't want to do that. And gladly, a web platform provides us with web workers, which act like isolated threads that work off our UI thread. So we can do as much work as we want there, and we're not blocking any of our rendering. And that's really nice, because then we can do like really heavy computations, like applying filters to images without having a single frame not showing. So this is a really nice tool that we can use. And we can spawn as many of them as we want, and we can spawn as many instances of them as well. We just need to be careful not to overload our computer, because that would also mean that our app would start yanking.
But I mean, you send them messages and then you're waiting back from them for a response. How is this different to a promise?
Well, a promise is a proxy for value not necessarily known when the promise is created. And web worker does all the work in the background and then send the results. So we can join those two and hide all the logic for adding event listeners and spawning things and listening for the results, and do all that with promises, and then have a better control flow and reusability in our code base. And one time I tried to play music with my browser, and that doesn't sound like a good idea, but I wanted to push browser and see how performant it could be. So I tried to play drums connected to my browser, and the problem wasn't really noticeable at first because everything was working smooth. But as I added more and more interactions and animations to my website, suddenly the beat went off and music was not listenable or enjoyable anymore. So I tried and created a web worker to take care of all the scheduling required. And with that, I got a really smooth result, because my main thread was not blocked with all the other work, and the timeouts were firing correctly. So let's look at how code for that works. In the file I call 𝙒𝙗𝙗, this is a part of our client. We initiate a new service work or web worker We just provide a URL to the file, and then we add an event listener to it, just listening for the messages. And somewhere in the app, when we want to trigger something in the future, we just call that timeout worker and send a message to it. And then in the timeout worker, we listen to messages. And on each message, we just set a delay when we want to receive it back. And that worked really smoothly, and I could listen to my music again. So this is all good, but sometimes we would like to share a worker between different tabs or do some other things that are not so isolated from our app. And that's where service workers come into play. So when building a progressive web app, we often ask ourselves questions like, what happens if network fails? How to get data when the website isn't, or we don't have internet connection, or the website isn't running, or how to send data after we get back. So if we're offline, we want to do something with our app and then have it synced later. And this is where service workers really help us. They're a special kind of workers that are always running, and there can only be one instance of a service worker, of a specific service worker at all times. And it's shared between all the different tabs, and service worker can send messages to those tabs or do some other things. They can also act as a man in the middle between our server and client, thus serving as a caching tool.
Oh, wait. Did you say man in the middle?
Yep.
That really doesn't sound very secure to me.
I mean, service workers are still part of web platform, and they have the same rules that apply to regular web applications, or our regular scripts apply to service workers. So you can't really read coarse responses if they're not meant for your site or your code to process them. So
All right.
let's see how we can implement a simple caching solution with a service worker. First, we register a new service worker somewhere within our app, in our app, and we just tell the name of the file, and that's where browser starts its process, registering this one. And in the service worker, we then attach an event listener called install. So this is going to happen when our service worker is being installed for the first time, or a new service worker comes in as an update. And in here, we can wait until some actions happen. And I just added a placeholder function setup where we could do all those things in async. So we could, for example, pre-cache all the files. And service workers usually get activated after the reload, but we can, of course, skip that behavior by calling skip waiting. And that would mean that our new service worker is active immediately after it's done with install. But that can be, of course, dangerous, because if we have some logic in service worker that depends on logic of our app, they could get out of sync. So this one is not really the thing that you should be using most of the time. And we can also attach a fetch event listener. And in this case, we are going to filter out all non-GET requests. And for all GET requests, we're going to call a function called cache first and let that respond to our event. So cache first is just a regular JS function. And in this one, we just need to open the cache, try to find a match. And if we have a matching cache, we can serve that. Otherwise, we can let server take care of that response and maybe cache it later, because this one would only work if we already pre-cached most of the things.
Okay, so we can do caching. Big deal. Anything else?
Well, of course, we can do push notifications. We can do background things, so users could click something while they're not in the app or while they're not on the network. And when they close the app and come back online, the web service worker would automatically synchronize all the content to the server. And we could also build apps without servers, so just having one app in multiple tabs, sharing the same storage, having the same event bus and everything. So we can do lots of things.
Awesome.
But now that we have some basic tools, let's look at our primary definition of progressive web apps.
So we've at least fundamentally seen that PWAs can be reliable and fast and engaging. And now we want you to decide which track you're most interested in hearing about next. We're going to show you how you can extend offline features with service workers in the reliable track. Or we can show you how to do heavy computations with WebAssembly in the browser. Lastly, in the engaging track, we're going to be implementing push messages with service workers and also give you some tips on how you can implement a push service on your backend or application server. So it's poll time. The cat is on the screen. Please change your tab and cast your vote. We are very interested which track you're most interested in hearing about next. Offline features and reliability, speed and performance with WebAssembly, or engaging PWAs with push notifications. Oh man, this is a tough one.
Yeah. It's not a binary question anymore, and we have lots of different choices and lots of different opinions. So,
but it's always compiled down to binary. You know, where do all developers meet at the end?
No,
in the assembly. Awesome. Okay, it looks like that this is it. WebAssembly has won. So I'm giving over to Klemen to show you what we did with WebAssembly and how WebAssembly can help you do some awesome and crazy things in the browser as well.
Yeah. So let me first tell you some things about WebAssembly. It's a web standard, and it lets you compile other static type languages like C, C++, Rust, even C#, and a whole bunch of them to something that our browsers can read and actually run. They're faster usually when you're doing larger jobs and more heavy computation. And they let us have features within our browsers that otherwise wouldn't be possible.
But I mean, why do we need this? JS is fast. Isn't JS good enough?
Yeah, I mean, it is until you want to, for example, parse an image and figure out what barcode is there. And that's something that's really heavy on JS. Even all the optimizations still aren't worth it. And on the other hand, we could have an app developed with lots of business logic, which is separated from the UI logic, and we could just take that and use it in our JS app. So separating concerns would really help us here.
Yeah, separating concerns and isolation and all that. But I mean, how does this work? Does it work in its own thread like web workers do, or
no? Actually,
how do you include WebAssembly?
Yeah, they actually run on the same thread that you're calling WebAssembly from. So they're still blocking your thread, but it doesn't need to be your main thread. You can offload WebAssembly code into a web worker and then let it handle all the requests from our app.
Cool.
So yeah, I'm gonna demo how we managed to actually create a barcode scanner in one of our apps that we were doing. And we tried first with just using JS library that can do that. And there are some on the market, but they were all so slow. Like the average time to get a barcode was near like 50 to 100 milliseconds, and that's just not good enough when you want to check 60 frames each second if there's a barcode in there. So first, then we decided to go into and try WebAssembly. And the first step you have to do is install lots of different tools and compile some of those tools, just in order to be able to compile, for example, C language. And there's 𝙒𝙤𝙢𝙢𝙦𝙢 tool that does just that. It provides a nice compiler for C or C++ code to our WebAssembly. And after we've done this, we can now write some C code. And here we have a signature for our function in JS that will be listening for the result, because this also works like with events. So you call a function and then call back another function. So this is really similar to how we're used to do with callbacks. And we can, of course, wrap that in a promise. But in here, the JS output result will be our JS function that's going to be called with a result. And then we have a scan image function, which is C code. And this one uses library called 𝙒𝙬𝙗, which is one of the longest lived barcode and QR code scanning libraries in C. And we can just pass that image or image buffer in there. And after we get the result, we can post that back to JS. And of course, we have to compile that and provide another JS file that serves as an interface between WebAssembly and our code. And after we compile that and include it in our app, we can just call it. So we first initiate the API that tells which function in WebAssembly to call when we want to call API.scanImage. Then we set up a callback for the result, and where we will get our scan results. And the process of getting camera in the browser is first you have to open a video stream. You have to push that stream to a canvas, then read from canvas, send that image to a scanner, and when you get the result, you can do something with that. And we actually use this with React and hooks, and everything worked really nicely, because in the end, we just had a scanner component which we passed in like on barcode read, and we could control when camera is streaming and when we're actually scanning. So we could delay the scanning part until the user was sure that they want to actually scan things.
That's pretty cool, if you ask me, at least. And now we've seen how the browser works, how the browser handles your code. We've seen what we can do with web workers and service workers. And we've even taken a look at how we can compile more lower level languages to be used in the browser and kickstart our applications with that as well. But that's a lot of stuff that you have to think about. Leverage a lot of modern web APIs. It's just you're working against the browser to try and achieve a certain level of performance. But we also want to talk about Flutter today. And Flutter is a different kind of a beast. In the Google description, they say it's their UI toolkit for building natively compiled interfaces. But we believe it's even more than that. It's really fast, rapid, fast to pick up for web developers, fast to work with, especially the ones working with reactive frameworks. Dart is very semantically similar to JS as well. They say it's expressive. Flutter has lots and lots of pre-built APIs and widgets and other stuff. So you can really focus on putting everything together and making your apps look fantastic and work good, instead of having to deal with all the necessary plumbing and underlying issues or platform differences. So in that sense, you can really leverage your creativity and focus more on creating. And it's native, as in it compiles down to native ARM code with pre-built common differences. It's really, really fast. Actually, recent benchmarking tests show that for iOS developers, it's actually faster and better for them to write their apps in Dart and Flutter than it is with Swift. And comparing it to the Android platform, so to Kotlin or Java, Flutter basically achieves the same or very similar bottom line in terms of computational performance.
So this sounds like all fun and games, but we developers seems to be very opinionated on the topic of state management. How do we deal with that in Flutter?
Well, Flutter has a very big and active community backing it. There is a lot of approaches built into packages that are available to be used in production already today. There is really a lot of ways in which you can solve that, and it really depends on what your taste of state is. The most popular one probably is the provider pattern, also recommended by Google, and it's very similar to how the context API works with React for front-end developers. You can use the Dart RX implementation, or you can use the block, which was based on the Dart RX. And you even have Flutter hooks. So hopefully that becomes stable in the following months as well.
Awesome.
Really,
and just to answer your question, I like my state fast and clean. So this is really good news for me.
Good, good. But yeah, I mean, Flutter is still somewhat new, although it's been here for some time. It can already be used in production. And we are really eager to hear whether you have some previous experience with Flutter already. It's poll time. The cat is on the screen, or on Klemen's head at least. So please change your tab and cast your vote. Okay, it seems that the vast majority of you have no previous experience with Flutter. So we're gonna make sure that you understand Flutter, at least on a very basic level, coming out from this talk today. I think it's good if Klemen starts with showing you how you can compose your UI in Flutter and how the initial scaffolding looks like.
Yeah,
Klemen, go for it.
Thanks. So Flutter UI elements are named widgets, and they can be some of the things I will mention. They can be a whole app wrapper. They can be a scaffold of a screen. They can be app bar, center, column, text, even floating action button and icons. So everything in Flutter that hears on the name UI is a widget. And we compose those in a tree. It's really like DOM tree or JSX tree in React. And it reflects what our users wants to see, or what do we want our users to see. And here's a simple snippet that provides an overview of a really simple app and how easy it is to build this UI in Flutter. So in the top, we see that we're initializing our material app widget. We're adding a title to it and adding a scaffold to our home route. We can also do other routes, but for the sake of simplicity, we just created one route called home. And then in the scaffold for our body, we just create a center container and add some text to it. And one of those texts is actually reflecting a value that's coming from our state. So on every state changed, we just re-render the whole tree, or just that isolated part in our widget, like we do in React actually. And then in the bottom, we add a floating action button, just to enable clicking and incrementing that counter.
But this is a very simple example. I mean, usually in the apps that I'm working with, these are not the components that I would use, at least not the basic ones that are shown on the screen right now. Can you extend them? What can you do in terms of customization?
I mean, the first layer of abstraction offers us to just set a config for styling. So it's similar to CSS, and we can add like background color, text size, border radiuses, and so on. But if we want to go deeper, we still can, and we can actually manipulate how the widget is painted to the screen. So we can actually, every widget can serve as a canvas, and we can draw everything. So we can achieve all the effects that our designers want us to have in app, which is sometimes really hard on web, for example.
Oh, wait, you're saying that if I want that 70s look and have some wiggles on the top bar, I can do that?
Yeah, of course. I just
But how is
wonder if
that possible?
you're I mean, Flutter is using their own rendering engine, which they're packing in every app that we're building. And with that, they can take control of the whole screen and paint anything they want to the screen. So even native looking dialogues and everything is still rendered by Flutter.
Coolio, awesome. And this all that looks very easy. I mean, it's very easy for me to understand the code. But what about platform-specific code? I mean, I'm sure there are cases where I would need to write that one as well.
Yeah, like when it comes to platform-specific code, it usually means that there's not a library yet on the market that would solve your native problem. And you can easily write your own platform-specific code and just bridge the connection between platform and Flutter.
Can you show us how that would look like?
Yeah, you can just switch to the next one. Awesome. So Flutter provides us with a binary message channel, so we can send messages to platform and receive them back or listen to them, because we can make as many of them as we want, and we can trigger some functions in the native code and as well some functions in Flutter. And if we look at a demo code of what we did, so we were trying to scan image or scan barcode with Flutter as well as we did with PWA. And we found an awesome library from Google that took care of scanning. We also find a library that captured the image and presented us with camera view. The only thing that was missing was actually turning Flash on and off in that library. So we just copied that library to our project and extended it with a new functionality for setting Flash on and off. And in this code sample, this is Flutter. We can see that we just need to create a meta channel and give it an ID so they can connect with the message channel that native platform is creating. And then in the bottom, we're just calling invoke method, giving that method a name and a map of parameters that we want to use. And if we look at Android code, we can see that we're just listening on method call event. That's going to happen sometimes. And then when it comes to figuring out which function to call, we can just switch code and see if it's setFlash method that we invoked earlier. And here is the IIS code that shows exactly the same thing. So it's really no hassle to set this up.
Okay, so you showed us now that we can write platform-specific code to connect Flutter with some missing native features. But I mean, is there anything else we should use this for? For example, you have shown us that we can use WebAssembly on the web to do really computational heavy stuff and make it work in the browser. Should I use the same for platform-specific code in Flutter?
I don't think so, because as you said, Flutter is compiled down to native code with Dart. And that means that all of the code is gonna run performantly out of the box. So we're not having any interpreters in between. So we can just let the Dart take care of all our performance-heavy operations. And we also have threads, so that's also not a problem that we want to solve with Flutter. Yeah.
But for people not experienced with Kotlin, Java, or Swift, there's already a lot of pre-built packages available for Flutter, right? That you can just use to connect your Flutter app with the native channels.
I mean, the community is exploding, and there's a library for everything. It's almost like NPM, but for widgets and native features.
Awesome. Cool. So again, we're at the choose your own track section, and we are very interested into hearing what you're most looking forward to hearing about next. In the rapid track, we're gonna tell you about our experience with team composition and developer onboarding for one of the projects that we did for our client. And in the expressive track, we're gonna show you how you can do animations in Flutter using built-in APIs, and then you can decide how hard or easy it is. And in the native track, we're gonna continue from the previous code example and show you how you can customize the UI for both platforms in the same code base and what you need to do to make that work. So I can see that some of you are already voting, but officially it's only poll time now. So the wonderful cat is back on the screen. Please change your tab and cast your vote.
I hope we're gonna talk about expressive track.
It looks like it's gonna be native, unless some of the passive voters now reactivate and help you out.
Vote for Klemen. No, just kidding. Vote for Žiga, please.
Oh damn! Nobody wants to hear me talk. Klemen, it looks like you're up again. So please continue and show us how you can customize your UI for both iOS and Android.
So previously, I mentioned that Flutter takes care of all the painting in our app. And that means that they also do all the native pop-ups by themselves. So they're actually replicating the platform look and feel. They also replicate things like physics when you're scrolling, and there's different behaviors on different devices. Because now we have Android, we have iOS, we also have desktop and web. So those are 4 different platforms with 4 different kind of physics systems and styling systems. And if you wanna take all of those into account, Flutter is really there to help us because they take care of most of the things out of the box. And that comes very handy when we're building a custom UI that doesn't change between different operating systems. But if we have some kind of more native look and feel, at least for some parts of the app, we can just toggle based on what we're showing based on what OS we're working on. So if we look back at our code from before, this is the same copy of the code that we had for our counter screen. And now let's look how it would look like if we wrote that for iOS. So we would need to change a wrapper, and that's just to make it look like that. Both versions would still work on Android or iOS or web. And here we see that we need to change all the material references to Cupertino, which is a library in Flutter core that mimics iOS. And because we don't have a button or floating action button on iOS style apps, we will just add a simple Cupertino button in the section with text. So let's see how this works. And what I actually made with that script was that every time we increase the counter, we change the look and feel of our app. So every time we're changing between material design and iOS design. And that's really like fast, it's still smooth, and it shows how easy it is to actually make those different UIs. But in the cases where we want to have a different, like same layout, but different kind of components that we want to show, we can just create our own wrappers that decide which component to render or widget to render. Is it going to be iOS 1, Android 1, or something completely else? And Flutter widgets are also, so with Flutter, you're also able to draw things in AR and use AR features of your device. And since Flutter is painting everything by itself, we can actually map some Flutter widgets on the surfaces when we're doing AR. So for example, we could hold our phone on the table, over the table, and have another phone being shown on our table or desk, and then tap on that phone through our phone. So that's really awesome.
Cool. Thanks, Klemen. And we've now seen what is possible with the help of modern web APIs and how we can build almost native-like experiences with progressive web apps. Although the support is still somewhat limited, especially on iOS. But not only that, we've also seen that by using Flutter, we can create highly engaging and interactive, blazing fast applications for multiple platforms at the same time. But now the questions that we need to ask ourselves is, should I or should we start migrating all of our apps today? What do you think, Klemen?
Well, I think that one does not simply go and refactor their app over the night, because that would be really strange. And it's really impossible scenario when you have a huge team working and you can just change a framework overnight. But you can start by introducing Flutter to your existing apps, because you can show a Flutter screen in your regular iOS or Android app. But if you're facing a major refactor or building a new app, you should definitely give Flutter a go.
Yeah, but I mean, it really doesn't only depend on you. It mostly depends on your users.
Definitely.
Flutter and progressive web apps are just pieces of technology that you can leverage to achieve your goals, whatever those might be. And it depends also on the features that your users are expecting you to have. Looking at this very limited and concise table, you can already see that things don't look the same for all three. The progressive web app support is great on Android, but it's very lackluster on iOS. And with Flutter, you can essentially do whatever you can do with any other native application. But it also comes with some of the limitations that other native apps come as well. If you're building a productivity tool where you want to enable your users to receive push notifications because they need to react quickly and receive feedback fast, if you have some users on iOS, then probably progressive web apps are not the way to go. And if you want to have highly immersive interfaces with lots of micro interactions and animations, and you want it to run very fast, then I would assume that Flutter is probably your best choice. But Flutter has one limitation that is especially important to consider. It's also a limitation of other native apps as well. Because progressive web apps run in the browser, they're essentially just websites. And whenever you want to update them, you just send a request to your server and receive the new updated code from it. So all your bug fixes and feature updates and whatever else you might need is going to be there. But with updating Flutter, you still have to go through the regular channels, through the App Store and the Play Store. So you're somewhat at the discretion of your users, whether they want to update your app and their device. So at the end, I mean, maybe you do, or maybe you don't. The bottom line is that we as front-end developers, we're building software for people. And we should do everything in our power to provide our end users with an enjoyable experience rather than a technological nightmare. And the software that we build should empower our users, enabling them to work better and more productively, or just maybe engage in more meaningful interactions in their private lives. If you think that any of these technologies will help you do just that, then I think you already have your answer. And with that, I want to wrap up today's presentation, unless Klemen has some last words to say.
Well, I would just like to make a small plea. Please wash your hands after all those interactions. Thank you.
Thank you so much for this session. It was so fun to watch. I mean, you did an amazing job. We've got a bunch of questions for you. Are you ready?
Yes.
Born ready.
Good. Okay, so the first question is, or it's more a statement, but I'll try to phrase it as a question. So it's UX, does it take both design and performance into account?
I can go with this one. I mean, for me, it's maybe easier to rephrase the question. If your application is unpleasant to look at, and if your application is laggy and unperformant, what is the user experience of that application going to be? I don't think that it's going to be very pleasant for the users to experience your ugly and laggy application. I hope that answers the question or the statement.
Yeah, and I would just like to add that when it comes to UX, it's not just UX and UI specialists that need to take care of that. We as developers and other members of development team, like QA experts, should also be responsible for the good outcome, because that's what we're building. We're all building just apps for our users.
Yeah, true. Second question. Can we make web apps with Flutter, or is it more specific to mobile platforms?
Yeah, we actually can. And I think they're already out of alpha release with that one. So you can take your existing Flutter app and just compile it for a web.
Actually,
Cool.
The underlying rendering engine that Flutter uses, 𝙒𝙗, is the same one that the Chromium engine does. So it's very compatible between the two. It's essentially the same thing.
Okay. Third question. Progressive web apps works perfectly fine on the Android platform. What's the current status of camera support in progressive web apps for iOS, especially when saved to home screen?
Well, Apple actually shipped that feature after a few years of battling over the forums, but they released it like 2 weeks ago, and it's ready with the new version of iOS.
But
Well,
you
that's
only
nice.
get the basic camera access. Advanced camera features are still only available to the Android platform. Barcode scanning, for example, is one of them.
Okay. Hopefully it's coming sometime.
Yeah.
Yeah, well, probably it's mostly a political decision from Apple. There is really no technical reason why this shouldn't be supported already.
Yeah. Okay, another question here. What if you would use computational heavy stuff in Flutter and then use the web application of it? Will you be able to use WebAssembly then?
Yes, probably because as Dart still compiles, it can compile to WebAssembly, and the whole thing is running in WebAssembly. So with threading, I think you should be able to actually run that in browser. And otherwise, you still can make modifications based on platform, and with that, you can do anything.
Okay. Can you give some examples? Sorry, did you want to say more?
Yeah. And you also have to consider that you might not have the same issues on a desktop application that you have on a mobile phone, because the desktop computers are usually a lot more beefed up in terms of performance. So if you would need to use WebAssembly to help yourself in a PWA running on Android, you might not have to do the same thing if you're running that as a desktop app in your computer browser.
Okay. So can you give some examples of complex production Flutter apps?
Yeah, you probably can. Your best bet is to Google it.
Yeah, but we were attending a Flutter conference I think it was in February this year, and there are actually like 20 bigger apps that are currently running in Flutter. Even an app with more than like million daily users. So I hope that answers the question. But I think that Giga found interesting benchmark a few days ago.
Which one are you talking about? I have
The one
many
comparing
benchmarks.
the one comparing iOS native app with Flutter app on
yeah,
iOS.
I've mentioned that one. Yeah, so some people were working on performance tests, and they were looking at how essentially a similar app performs in Flutter or written in Swift for iOS or Kotlin for Android. And what they found out is that Swift actually is the worst in terms of performance. Flutter performs better than Swift, and Flutter performs almost as good as Kotlin, or the difference is basically unnoticeable, or could just be due to a testing error or margin. But answering the question, I think one of the bigger users of Flutter right now, at least I was reading about this a couple of weeks ago. I think that Alibaba and BMW are transferring some of their apps to Flutter.
Really?
They probably have the most hits among all the other companies, although there are still some very big giants on that list as well already present. But it's up to us. It's up to us. Everyone who's interested in Flutter, we should start creating our apps with Flutter and showing the world that it's a strong enough technology to support that.
Yeah, one app at a time.
Exactly.
We have one final question for you. It says like this. So this is the same as React Native, and notifications are still platform specific. So are there any particular advantages over Flutter over React Native? Not only in the UI scope, because that's similar, but other advantages.
Honestly, React Native has come a long way since a couple of years ago. It's getting better, but still Flutter is in an entirely different league. It is a lot more performant than React Native is. It has one key differentiating feature, and that is Flutter actually is built with Dart, and all the source code is inspectable. It uses its own rendering engine, 𝙒𝙗, which means that you have really complete control over what your layout looks like. Although you can still use React Native to build multi-platform apps, you can use Flutter to build native apps on multi-platforms. So it's really a native experience in its own. The developer experience, at least in my experience, is a lot better as well. I never enjoyed working with React Native, but Flutter has this strange pull that just sucks you in as soon as you start building with it.
Nice. Maybe I'll try it out sometime. So that was all questions that we had. I'm curious now what your lies were in the beginning. Can I guess first?
You need to guess first.
I need to guess. Okay. So Žiga, I think that you play classic piano, and I think that you played metal in high school, but I don't think that you played folk music.
Yeah, I actually did play folk music as a DJ. The lie was that I did play heavy metal as well in a band, but that was in elementary school, not in high school.
That was a trick question.
It was.
Okay, Klemen, I don't think that you commute by skateboard.
Well, I actually do, but I don't understand monads.
Okay.
Yeah, sorry.
Nobody does,
Well,
Klemen. Don't feel bad about it.
Well, thank you once again so much, Klemen and Žiga, and thank you to all of you who participated in this live stream. I hope that you enjoyed it as much as I did. And we got more coming up for you. So if you're interested in micro frontends and microservices, if you